Namaste ChinaTech Chamatkar family. Jensen Huang just declared war on China's manufacturing empire. NVIDIA is going all in to bring factories back to America. But can robots really beat China's $6 per hour wages and lightning-fast supply chains? We're breaking down the full plan, from Arizona chip fabs to Texas robot armies. And yes, China, this is your wake-up call. Stick around till the end for the 2030 prediction that could change everything. NVIDIA CEO Jensen Huang has been vocal about reshoring U.S. manufacturing, framing it as a national security imperative and a response to President Trump's America First agenda. In recent speeches like his October 28, 2025 keynote at NVIDIA's GTC conference, Huang declared, "We are manufacturing in America again. It is incredible." He credited Trump's policies for spurring U.S. investments, positioning AI as an industrial revolution, demanding domestic production. But what does going all in really entail? NVIDIA, now valued at over $5 trillion, is leveraging partnerships to build a US-centric supply chain for its AI accelerators, servers, and networking gear. The plan emphasizes vertical integration to reduce reliance on Asia, especially amid US-China trade tensions. Key pillars: chip fabrication in Arizona. NVIDIA's latest Blackwell AI chips entered full production at TSMC's Fab 21 in Phoenix in October 2025. This $12 billion facility, subsidized by the CHIPS Act's $6.6 billion grant, will produce up to 20,000 wafers monthly by 2027. Huang called it a foundational pillar for U.S. tech sovereignty. Servers are assembled in Texas via partners like Foxconn, while networking equipment is built in California. This creates a full-stack U.S. ecosystem. By 2026, NVIDIA aims for 20 million chip shipments worth $500 billion, with 30 to 40% U.S.-sourced. Long-term, $500 billion total investment in U.S. manufacturing by 2030, including 7 new supercomputers for the Department of Energy. Incentives. Driving it. The CHIPS and Science Act's $52 billion and Trump's tariff pauses on semiconductors make it viable. Huang noted tariffs' near-term impact is minimal thanks to these boosts. This aligns with Huang's July 2025 White House meeting with Trump. It's not just NVIDIA. TSMC's Arizona fabs will serve broader U.S. needs, creating 6,000 jobs. Can robots offset high U.S. wages? Yes, but it's part of a bigger automation play. Automation, including robots, is central to making U.S. manufacturing competitive despite wages averaging $30 per hour versus China's $6 to $8 per hour. Huang has repeatedly tied AI to reindustrialization, arguing it offsets labor costs by boosting productivity 10 to 20 times. NVIDIA's robotics angle. NVIDIA's Isaac platform powers AI-driven robots for factories using Omniverse for simulation. In Arizona, TSMC's fabs deploy NVIDIA-powered robotic arms for wafer handling, reducing human error by 90% and enabling 24/7 operations. Huang envisions lights-out factories where AI agents manage entire lines, slashing labor needs by 50 to 70%. Efficiency gains. Robots handle repetitive tasks while AI optimizes yields. NVIDIA claims 15% higher throughput than human-led lines. This mirrors Tesla's robot-heavy gigafactories, where NVIDIA tech cuts cost 20 to 30%. US labor is 4 to 5 times pricier, but automation drops effective costs to near parity. A McKinsey 2025 report estimates AI/robots could add $2.6 to $4.5 trillion to U.S. manufacturing GDP by 2030, largely via reshoring. Huang and others argue that AI and digital twins are critical enablers of efficient onshore manufacturing. These technologies allow companies to localize production while maintaining global competitiveness by boosting agility, reducing costs, and improving resilience. Onshoring reduces vulnerability but can be more expensive without advanced technology. AI and digital twins bridge this gap by making local production leaner, smarter, and more cost-effective. Role of AI in onshore manufacturing. Predictive analytics. AI forecasts demand, machine failures, and supply needs, reducing downtime and waste. Process optimization. Algorithms fine-tune production parameters. Quality control. AI-driven vision systems detect defects in real time. Digital twins, the virtual mirror. A digital twin is a virtual replica of a physical asset, process, or system. Manufacturers can simulate production lines before making physical changes, saving cost and time. Real-time monitoring. Sensors feed live data into the twin, allowing instant adjustments. Resilience. If disruptions occur, digital twins help test alternative workflows without halting production. Combined impact. Agility. Rapidly adapt to new product designs or market shifts. Efficiency. Reduce energy use, material waste, and labor costs. Sustainability. Optimize resource use, aligning with green manufacturing goals. Scalability. Once proven, digital twin models can be replicated across multiple facilities. Huang's core point. Researchers like Jensen Huang emphasize that AI-driven digital twins are transformative. They enable sustainable, resilient, and competitive onshore manufacturing by combining advanced digital techniques with deep production knowledge. In short, AI and digital twins make onshore manufacturing viable by offsetting higher labor and operational costs with intelligence, automation, and adaptability. Would you like me to break this down into a real-world case study? For example, how automotive or semiconductor companies are already using digital twins to reshore production. A strong real-world case study is Siemens' use of AI-powered digital twins in its onshore manufacturing plants, particularly in the US and Germany. Siemens faced the challenge of producing highly customized products closer to customer markets. Onshoring production meant higher labor costs, so efficiency and flexibility were critical. Siemens created digital twins of entire production lines at its Amberg electronics plant in Germany and its Charlotte advanced manufacturing facility in the US. These twins integrate AI, IoT sensors, and real-time data to mirror every machine and process. Engineers can simulate new product designs and predict bottlenecks. AI's role: predictive maintenance. AI models analyze sensor data to forecast machine failures, reducing downtime by up to 30%. Process optimization. Algorithms continuously adjust parameters for maximum efficiency. Quality assurance. AI-driven vision systems detect microscopic defects in real time. Impact. Productivity. Siemens reports that its Amberg plant now operates at over 99% quality rate despite producing over 17 million units annually. Flexibility. The Charlotte plant can switch between product variants quickly, enabling mass customization without slowing output. Resilience. By simulating supply chain disruptions in the digital twin, Siemens can test alternative sourcing and logistics strategies instantly. Sustainability. Energy consumption has been reduced by optimizing machine usage and minimizing waste. Do 3 things, like if this blew your mind. Subscribe. For similar thought-provoking content, share. Let's start the discussion in comments.